Good afternoon. Thank you for joining us. I'm Robert Baylor, Director of Communications at NUCA. Welcome to our latest webinar, sponsored by NUCA Gold Level National Partner United Rentals. First, before we begin, some webinar housekeeping. Today's webinar will be recorded, and a copy of the recording will be provided to all registrants and attendees. It will also be available in the next few days on NUCA's YouTube channel, which can be accessed via nuca.com. Now about your WebEx Meetings webinar screen. There are two buttons on the lower right-hand side of your screen titled Participants and Chat. Clicking on Participants gives you a list of webinar attendees. You can chat amongst each other, or you can send the host questions or messages. All participants are muted upon entry. Phone participants can use *6 to mute themselves. Questions will be asked at the end of the webinar. To ask a question, you can submit a written question at any time using the chat feature, and I will read those written questions to our presenter at the conclusion of this presentation. Now let's get started. June's NUCA webinar focuses on a little realized topic that can affect the safety of every excavation on a job site. Manufacturers' tabulated data guides competent persons in choosing, assembling, and installing a trench protective system, including a trench box. Our expert speaker will highlight key elements and tips in working with the tab data requirements, as well as deliver to our audience some recommendations for what to do when job site conditions change. Our presenter today is Mr. Joe Wise. Joe has been with United Rentals for 17 years. During his career, he has served in a number of leadership positions educating contractors on compliance and protective system solutions for trenches and confined space operations. In his current role with United Rentals, Joe provides strategic oversight to competent person training programs in confined space and excavation safety. Thanks so much for joining us today on NUCA's Webinar Wednesday. Joe, I turn the webinar over to you.
Thank you, Robert. And hello, everybody. Today, we're going to talk about a little bit of an overview of tabulated data so we get a sense of what it is and how it's used. We're also going to point out some important elements of what a competent person would need to know regarding the manufacturer's tabulated data. Not every size fits every solution, and every manufacturer does design their boxes or their shores slightly different, and we'll need to know and understand where to find those key differences. We're also going to take that information and then kind of show how relying on the manufacturer's tabulated data as conditions may change on a job can help us navigate through a safe workday. First, I'd like to start by talking about a survey that in 2019, United Rentals had helped distribute for the Center of Construction and Research. They had to do this research, and specifically for OSHA and NIOSH, to try to reveal at the time what was causing the related increasing trends of trench fatalities in our industry. Now, there were 637 respondents of those particular surveys that was a volunteer. As you can see, there's different statistics here regarding those that had attended and submitted one. Most of them, 70% or more, were veterans to the industry, 10 years or more experience. As you can see, the one that I've highlighted that really stands out for today's topic and why we wanted to bring this to you today is that 40% had indicated that they have a misunderstanding and use of tabulated data. It's important that as we recognize when we go to a competent person training class, it's certainly all about understanding 1926 subpart P, the 12 general requirements and all the appendices from A through F. But without the understanding of manufactured tabulated data, proper use, how to use and apply those particular systems and the right applications correctly, we can result in accidents and lives that can be changed forever. So let's go ahead and get started with this important topic. As it boils down to the competent person, we know that there's a lot of decisions to be made and safety that needs to be mitigated and managed on the job each day. The competent person has two areas of where they can go for this proper solution of compliance and worker safety. To the left, we see that the OSHA standards in 1926 subpart P. We know that the competent person shall abide by the particular charts and table. We also know that within these tables and charts, they're limited to 20 foot of depth, whether we're looking at the sloping guidelines, benching, timber shoring, or the aluminum hydraulic shoring that's laid out in Appendix D when there's not manufacturer's tabulated data available. That particular requirement gives us the guidance for that 20 foot or less depth solutions. Now couple that with manufacturer's tabulated data or site-specific engineering. Again, the competent person has to make sure they follow those particular guidelines. design criteria, any specifications and recommendations that are held within those particular elements. It's interesting also to note that, again, the manufacturer's tabulated data and the understanding of the standard has to be hand in hand. As an example, most manufacturers' tabulated data will re-emphasize the importance of a competent person by even defining that particular person. They'll also specifically lay out how in Appendix A, the competent person must follow those particular guidelines for soil analysis in order to determine the proper depth and types of soils certain systems may be allowed to be used in. Now, before we get into the examples, I want to break down again, just as an idea, the examples of the types of systems where we most commonly see and have tabulated data to use. So you're going to obviously be aware that this is necessary for the steel and aluminum trench boxes that are manufactured. Modular aluminum boxes, also known as MAP systems or Build-A-Box. The hydraulic vertical shores, like what's pictured here on this particular slide. Small hydraulic whalers, or even manhole braces that can provide more of a clear span solution. There's also the slide rail tabulated data that can be used for simple applications. As an example, maybe a 16 by 16 pit that's 20 foot deep. On the flip side, it's also important to recognize that not everything has manufacturer's tabulated data. The elements of this particular slide I want to point out is very important to recognize that it's not tabulated data specific. There is no tabulated data, for example, with a steel sheet. It may have a section modulus that's important for the engineer to understand its strength, for understanding what toe requirements, embedment based on soil conditions, water table, whatever may be there. But beams and plates are produced at a mill, and they have a heat number, and they have a certain yield strength of that steel. But by no means does that give any competent person guidance on at what depth they can be used at or spacing requirements of those vertical uprights. So again, it's really important that together these components make up a protective system solution, but it must be designed by a registered professional engineer. So let's take a little bit overview of what manufacturer's tabulated data is. Again, as we break it down, it's really just generic engineering for generic work applications. And we need to recognize that these have been designed, these elements of design criteria have been made up by a registered professional engineer. We know too that the data within it is helpful to the competent person to make sure that we use those particular solutions in a proper application. I want to stress this point. Use of tabulated data beyond what it's allowed is not permitted, either by the manufacturer or OSHA, as it states under the requirements for protective systems in 1926-652, unless prior written approval has been by the manufacturer, we cannot use those particular systems beyond their design criteria. It's really important that we recognize that element. As we know that this is really a map for the competent person to know and how to use this properly, those particular instructions and tabulated data need to remain on the job site during construction and while it's in use. We'll also find within tabulated data a lot of the maximum capacities, maybe the limits of exposure. Examples are like working depth or maybe even soil types that the systems may or may not be able to be used in. One thing's for sure, there needs to be continuous training as it relates to manufacturers' tabulated data. Not every job is going to always have the same solution applied. And as we look at various solutions, maybe even various vendors, it's important that we know that there isn't an industry-wide standard for tabulated data across the board. You'll find that there is differences sometimes with dewatering requirements, perhaps what's used or calculated for surcharges, time allowances, and even soil analysis. The key to all of this is to recognize that you need to make sure you understand the particular equipment you're using, specifically that manufacturer's tabulated data, and understand not just the tables and charts, but reading the entire document, the specific notes that are here within those documents. And we'll take a look at a few. It's important to recognize that it's estimated that 76% of trench fatalities happen in unprotected trenches. We can't forget that the remaining 24% of potential fatalities occurred where improper use or the application of a protective system was used. So again, The competent person must read and understand tab data to safeguard employees. As we look at this particular example of tabulated data, we can see this for a 4x20 steel trench box that's 4-inch wall. It lays out the maximum table of depth. We can see there they have listed the soils from A, B, C60, and C80. We recognize that in note 5 in this particular tab data that they specifically laid out the description of type C soil. Again, recognizing type C soil is not a soil that's recognized and laid out in the OSHA standard, but it has been recognized by engineers. It's been acknowledged by OSHA as an approved soil type that needs to be identified and can be another, again, step for that manufacturer to use as a depth rating requirement to use a particular system. It's important to also note that as we recognize in this example, the stamp drawing at the bottom right, there's sometimes a misunderstanding of what the date on those stamps are. It's not any type of an expiration of the use of that system. It's important to recognize that that date simply means it's either a signature date or a renewal date. Now, it's important that we know that as a competent person's responsibility, daily inspections are required. Inspections of the equipment are also necessary. So anything regarding the perhaps condition of that particular shield or shore has to be recognized by the competent person. And if it's defective, it has to be removed from service. And sometimes that use of the system to put back in service requires an engineer and the manufacturer to make sure that anything that is defective would be repaired properly. Here's another example of another tab data for a trench shield. We can recognize here that unlike the other one we just saw, we certainly have the type C60 soil of limits to the worst case scenario that we can apply this particular system in. So again, we want to make sure that we understand there are limitations. Not every particular shield by every manufacturer is going to be designed the same way. We have to recognize certainly too that maximum depth ratings for the pounds per square foot of that design criteria may or may not allow for the surcharge of construction equipment or a spoil pile. These things have to be thoroughly read and understood from that particular design and make sure that we work within that criteria. If you look at the bottom left on note number 7, again, we can also see that this particular manufacturer had listed a short-term exposure. Now, it's pretty uncommon for a shield to be used in any type of a long term. Any type of a shoring system or protective system is intended for temporary shoring, and it's designed as such. But there are sometimes those conditions where maybe for a jack and bore pit where a shield may be used. We need to recognize that that's got to be something that we certainly need to be aware of, and this criteria can only be understood if we read and understand all the limitations in the use of a particular table for that manufacturer. Now, as an example, I want to show you some vertical shore tabulated data. As we know, if we just went off of the Appendix D for hydraulic shores, we would be limited in its use of depth, also with regard to its spacing, and recognizing too that it's only allowed in type A and B soil if we looked at Appendix B in the standard. So when we use the manufacturer's tabulated data, as you can see, we can use this type of shoring in a type C60 soil. What does this mean? What's really important for all of us to understand is that when we have the use of hydraulic shores, we have to do soil analysis. It's critical that we confirm that that soil is cohesive. It may not, it may break apart with certain angular gravel that's present, but it's going to stand long enough for those particular trench walls for the installation and removal to be done safely. So again, it's important that as we talk about protective systems and manufactured systems in particular, that particular application of the Appendix A to do soil analysis is really critical and necessary to understand the proper use and spacing, for example, in C60 conditions for hydraulic shores. The spacing is very common in most of the manufacturers, that no more than 24 inches from the top of the trench and less than 12 inches is where the top cylinder can be placed. We also know that no more than 48 inches from the bottom is when the cylinder, center line of that cylinder can be placed as we look at that placement of the shores. but a backing is also sometimes needed. Now, the way hydraulic shores works is we have this creation of a soil arching effect. Whenever there are shores placed as the design of the engineer criteria are laid out in the tables and charts, with that particular pressure of pounds per square foot of fluid pressure that we're putting into the shore, which is 750 to 1,500 pounds per square inch. That type of pressure creates the arching effect. So what's important to know about the backing criteria is you can see there's listed 8 different examples of what is approved in this example of GME's hydraulic shores. However, those particular elements, that particular backing of like 2 sheets of plywood, or perhaps the 1/2 inch minimum street plate, that's not a structural support. Again, the support comes from the strength of that cylinder as it's placed properly and exerts the proper amount of minimum pressure by the manufacturer with the bucket pump. When that's done, again, the manufacturer, as you can see, doesn't always require the backing. In a type B soil, if we can determine that that is a B soil, and that's the key to that criteria, we have to do the analysis of the soil strength. It doesn't necessarily require that that sheeting is used. Again, we have to make sure we're following, though, certain criteria of depth restrictions and spacing of those shores. It doesn't totally remove the responsibility of the competent person, because within the notes you'll see it asks that the competent person has to monitor the face of the trench wall for any possible sloughing that could come off the face of the trench. Again, soil that would be coming in over the top of the worker. So again, it may be necessary to use that fin form. It's certainly best to be, more important to be safe to always have it, but there are criteria that can save on production perhaps, and the amount of tools necessary to install shores and be within the framework of that criteria and design. Most manufacturers of hydraulic shores also illustrate the possible placement. Again, giving that competent person a visual to how they need to be installed. And as we know, looking at the far right, you can see that in that scenario where we have shores that are stacked, whether it be a vertical shore like that or single shores that are being stacked, they have to be placed and kind of situated where we can do the installation from above ground. That's the key to the installation, making this safe. So you can see they're offset slightly. Again, that's for the proper use of the tools of the removal hook and release tool, as well as the hose from the bucket pump that can be used on that lower shore to have access. Again, everything's installed from above ground, and it's necessary for us to do that properly. So when we talk about spacing requirements, with whether it's a single shore or a double vertical shore, it's really important we follow those particular guidelines and those safety requirements to install and remove everything from above ground. Let's take a look at the modular aluminum tabulated data for what we call maps or build-a-box. Here, what I want to point out is, again, just an idea of what we might miss if we're not looking. It's important to know that sometimes we might have used a build-a-box and perhaps a manufacturer, and way we used it before, called out that 36 inches on center for any time we have an open end, say a 3-sided application or a 2-sided application of the use of a shield like this. But we can't always assume things. And in this particular instance, I wanted to point out with this particular manufacturer, they have a requirement of a maximum spreader clearance on the 2-sided or 3-sided configuration is 34 inches on center for those spreaders. So again, we can't just apply assumptions of what we've seen before. We really need to take the time to look at the manufacturer's tabulated data and follow those guidelines and criteria that are spelled out within their instructions. There's certainly limitations to most tabulated data, and I want to cover some important ones because, again, it's necessary that we're not using equipment that's intended to be safe in a wrong manner that could cause an injury or an accident, perhaps even a fatality. One thing that's common that we need to make sure we do correctly is the fact that steel plates behind shields, it's not allowed. Whenever we have steel plates that we're trying to use on the side of a shield to extend that protection either above the top of the wall or below the bottom, what we're doing is we're adding additional surface area to the tributary area, and that's an engineering term. But basically what it is you're adding additional loading against that panel that has a specific design criteria. And when we extend it either to the bottom or the top of it, we're adding additional load to that particular panel that it wasn't designed to withstand. So it's really important that we need to make sure that is outside the limits of tab data. And we would need to get an engineer involved to even consider doing something like that in a safe manner. Another thing with road plates is sealing the ends of a trench shield. As we know, trench shields are used primarily for laying pipe and we have open ends, but in some cases, maybe up against the end of a trench run or for whatever other reason, maybe setting a vault or a structure, we may try to cap the ends of a shield. Steel plates, I know, have been a common way to do it. We're going to talk about the right way to do it, but it's not allowed if it's not followed by the manufacturer. More to come on that. Again, when it comes to steel sheeting or plate, having them bear up against the trench shield spreaders or even vertical hydraulic shores is not allowed. For the most part, it's because those particular situations, they're not designed to have any type of a vertical load to withstand. So again, an 8-inch spreader pipe, Schedule 80 pipe that's in a collar, that's a 12-inch collar on a panel of a trench shield, that particular, say a surcharge or a collapse of a shear wall collapse that's 3 to 5 yards of dirt up against that road plate, that could be devastating. It could actually cause that spreader to fail, and then we have a major accident. And the same with a 2-inch cylinder for a hydraulic shore, not designed for that criteria. We'll look at proper ways of how we can have end protection down the road here on this presentation. Surcharge loads, I've talked about them. Most manufacturers, but not all, have always calculated that 2-foot minimum distance of what's required for the spoil pile. When we start to look at busy job sites where maybe there's a crane or heavy lifts that are happening near the edge or close to the site of an excavation, we need to really understand that those particular surcharges, maybe even from road traffic working alongside a highway, can have an impact to that protective system. And we may need to take further guidance from an engineer. We also saw that, again, some of the tab data may restrict what types of C soils. Some may allow something to be used in a C80 soil condition, some may not. Some may not recognize a C60. So we just need to be aware of all that, and it really starts with starting with the soils analysis that's required by the manufacturer. Duration of exposure is another thing that we may need to be considered and looking for. Intermixing different manufactured components. This is typically not allowed, and it's a limitation to most tab data. Again, it's going to be dependent on what that manufacturer allows. So I would again encourage you to look at that, not just to do those things and intermix different components, for example, of hydraulic shores. We need to make sure that we're following the guidance of the manufacturer. Anytime we would modify a particular system, as an example, maybe we decide we want to have a plate welded on the end of a steel shield, or maybe something to extend an aluminum shield, that can't be allowed. It's adding more pressure against the design of that shield, and it has to be approved. Modifications like that are not allowed by the manufacturer and must be approved in writing before doing so. So now that we've had a chance to kind of review some of these basic elements and differences among tab data, I'd like to take the moment to kind of apply a few job site situations that can occur and how the understanding of tab data can help you navigate through a safe workday as a competent person. The first one I'd like to take a look at is when trenches get a little wider. It certainly happens. You know, we get a particular job, we know we're going to try to have a certain compaction trench, and we get a width of a spreader that we deliver, trying to work around what we have, but maybe because of the soil conditions are bad or things change, that trench gets wider than what we anticipated. We know also, and this is important, that shields are not designed to prevent cave-ins, but they are considered more of a passive protective system. So let's take a look at what the standard says. First, as it mentions, shields have to be installed to restrict any lateral or hazardous movement. So in other words, we need to make sure that it's not going to be moved off center or affected by a potential collapse. As you can see from the manufacturer, it also reinstates that. And specifically in this example, it gives an example of no more than 12 inches of overcut from the outside of that particular shield, and the distance between the outside of the shield and the inside diameter of that trench. So let's talk about some of the common, what we see across most manufacturers in our industry. So depending on the manufacturer, again, there may be some slight differences, but here are some commonalities. One is you would want to backfill at least half the height of your soaring system on each side. So looking at the picture to the right, you can see that the trench became wider than what the box was. And using that backfill to make sure that we fill it up to at least halfway the shield is really important. Again, the key here and what's required of the competent person is to make sure it's being used and installed to restrict any lateral or other hazardous movement. Now, GME specifically spells out a maximum of 4-inch gap on either side of the trench seal. Again, where I've said speed shore is more than 12 inches, no more than 12 inches overall. Now, again, just imagine a 3 to 5 foot cubic yard of soil separation from a shear wall collapse with a shield that's not a lot of weight. In many cases, those soils can weigh up to 15,000 pounds. It can cause some damage. It's going to move that shield. We got to be aware of how we use it and make sure we apply that safety measure when the conditions on the job may change. Next, I'd like to talk about the trench when it gets a little bit deeper. So we need to break down a couple things here. First of all, if you'll notice to the left, I have a diagram and an illustration showing that we have 3 8-foot tall trench boxes of particular depth rating for each one and wall thickness of what that C80 depth rating is. So looking at this from the aspect of, is it already engineered? The answer would be yes, but these conditions have to be understood. We're 23 foot deep. The bottom box is rated in C80 for the full depth of 27 feet. Now let's take a look at some of the notes from the manufacturer's tabulated data. Number one, it does state that if there's ever a variance between tabulated data and the Code of Federal Regulation 1926 subpart P, this tab data shall take precedence. So obviously what we're saying here is everything we see within OSHA standard is the depth charts and ratings no more than 20 feet. But again, what is that applied to? The use of shores without tab data in Appendix D. It's timber shoring. It's the use of sloping and benching. Second note, though, in the manufacturer's tab data I want to draw our attention to is that soils have to be determined by the competent person. So again, we have to make sure that the soil analysis is being done with a visual and a manual test as it's laid out in Appendix A of the OSHA standard. So again, if these criteria are being followed, and then lastly, recognizing that manufacturers have certain components and elements of what has to be done to stack them properly. So we have to make sure that we're utilizing the stacking pockets as they were intended and as they were placed. We have to make sure that we're using the proper pins for how that needs to be pinned together from box to box. So all these things are important. And you may be asking yourself, so how do we safely install something like this? Obviously, the safest way would be to assemble all these boxes above ground. And then you got to think about the fact of, we talked about surcharge load, but something like this with these types of weights, without even figure and spreader bar, you're looking at about 31,000 pounds of just trench shields when you consider the 4-inch, 6-inch, and 8-inch walls stacked as they're shown, not showing the weight of the spreaders and stacking pins. We need to recognize that particular machine that's installing it has a surcharge load that could be impacting the sidewalls of the trench. So again, there's a lot of criteria we have to peel back in this application, but to answer that question of what about going deeper than 20 foot? If we have the manufactured systems and we have them stacked all the way to the existing grade, then we're compliant with at least that ask of was the engineering done, as long as we follow that criteria. Now looking to the right, I do want to emphasize, however, that some manufactured boxes don't allow shields at certain depths to have that vertical side lower portion. So just because it's referenced in the OSHA standard doesn't mean a manufacturer may allow it. And if we had this particular diagram shown where there was just one particular shield at the bottom and we sloped the rest of that distance, that would not be allowed. That would require the particular use in most cases of having that engineered. What would need to be engineered? The slope. Because as we look back to the manufacturer's tab data, it will state that the particular slope has to be in conjunction with what's listed in the standard of 1926 subpart P. So again, the details, that's where everything needs to be followed. And if we're not sure, we need to lean on resources where we can ask. And If that is falling outside of those parameters, we need to get an engineer involved. Another area I'd like to talk about that's obviously pretty common is, hey, what if we need more pipe clearance? And we're trying to utilize that and raising the box off the bottom of the trench. As we know within the standard, it does allow, and it says it shall be permitted, but only if a couple of criteria are met. Number one, the shield has to be rated for the full depth. So in this example of this illustration, you can see that we have some tabulated data that shows that the full depth actually goes to the very top of the existing grade, at the very top of that slope where it begins. And also no indication of any soil coming in behind or bottom of the shield. So again, it's important to recognize that exact verbiage from the standard is used in the manufacturer's tab data. So there's really no difference here, but we need to make sure that nowhere have we ever been able to be allowed more than 2 feet off of the bottom. So again, we have to make sure that we follow those criteria. If we work outside of this criteria, we need to make sure we get an engineer involved. The next thing I wanted to talk about is, again, going back to that shield and the idea of most shields are used and were designed to be productive linear trench applications. And they were never designed to really have the ends closed up. They were always intended to be opened, and having that required slope of a 1.5 to 1 or 34 degree angle away from the end of the shield. And you'll notice here that, again, we talk about what the OSHA standard says. We have to make sure that we're following the manufacturer's tabulated data according to their specifications. As we look at 7.1, in this particular example of the tabulated data drawn from SpeedShore, it emphasizes in that second sentence that I put in there, trench shields must always be used in a manner that loose or falling soil cannot go over the top or through the end of a shield. So again, we'll talk more about that proper solution on the next slide. And that proper solution as it relates to shields to cap the ends of a trench box, whether it be aluminum or steel, is to recognize that manufacturers have had technical data sheets that can accompany the proper application and use of a road plate, for example, to cap the end. But there's criteria, limitations, and measures that must be followed. The general guidelines that you'll find is, number one, all manufacturers state plates cannot rest against the spreader bars. They have to rest against the box walls. And that's required because, again, those spreaders are not designed to withstand a vertical load. Secondly, you'll also notice that most of them have no more than a width span of 5 to 7 feet. Why is that? Again, 8 foot is the common width of a road plate. That particular plate would not be able to rest on a box that's 10 foot wide safely. Obviously, we need to make sure that that has the proper resting against the wall. And again, anytime we have these criteria, I will tell you that every manufacturer is a little bit different. So we need to make sure that we have the specific tech data sheet when you know you're going to use a road plate to cap the end of a shield. We can't just grab a sheet of steel, place it on the end of the box, and call it good. There's criteria, some restrictions. Every manufacturer might be different. If, just like we have manufacturers' data, if we work outside of the technical data sheet, we would also need to have that in writing or approved by a registered professional engineer. So as you look at that end protection with hydraulic shores, the same thing has to happen. However, in the scenario where you have a 2-inch cylinder, again, that's not intended to design a vertical load, again, we go back to what does OSHA say? Again, OSHA says to follow what the manufacturer's tabulated data restrictions, recommendations, limitations are. Manufacturer specifically says no vertical or lateral load shall be applied to the cylinders. What we have to do in those scenarios, as you can see from the illustration, they have manufactured solutions like an inshore. Here you can see it operates very similarly with the use of a hydraulic hose, bucket pump, but would certainly have to be installed with the machine. But that particular design, as you can see, has a steel tubing and it's designed to withstand a kind of vertical load. And from the back end of that, you can use the approved backing recommended by the manufacturer. Here you can see what's illustrated is the overlap of some of the aluminum sheeting that can be used as an example. Let's talk about the placement of a spoil pile. Sometimes it can become a factor. Again, when we talk about what OSHA says, shield systems shall not be subject to loads exceeding those which they weren't designed to withstand. Earlier, when I was talking about some of the elements and criteria of certain manufacturers, it's important to know that most sometimes figure that 2-foot minimum distance of a spoil pile away from the edge of the trench or excavation. That's 72 pounds per square foot of surcharge. Sometimes it's not specifically laid out there, and that's when you may have to consider having greater distances of where that spoil pile needs to be. Here in this example, I've highlighted the 4.2 that's out of the Speed Shore tab data for double wall trench boxes that they specifically lay out, that imposed no more than 3 foot high as far as the spoil pile. So again, that criteria we need to understand. We need to look at it may require us to do different placement of the spoil pile. If we don't certainly have the easements or the space on the job site, it may require that we do something different with that spoil pile so that we don't exceed what that particular system was designed to withstand as far as surcharging. When water becomes a factor, as we know, this can happen. And what's important to recognize here, as we know it's part of the 12 general requirements, is employees shall not work in these conditions where there's accumulating water. It has to be controlled or diverted. One thing I would mention is that's very common with most manufacturers' tabulated data. We have to prevent that. And also it needs in most cases to be, dewatering to the base of the excavation or the trench. One thing that's important to recognize here is in the actual nature of removing those particular liquids, the water, whatever that is at the bottom of the trench, it needs to be done. But if we're just putting in a 6-inch pump or 4-inch, 2-inch pump to dewater in the middle of this build-a-box, as you can see pictured, we need to recognize that the hydrostatic pressure against that system can make it difficult to potentially get out, or potentially also could be such a condition that would also cause it to cause deflection, just because of the weight of the soil, the amount of hydrostatic pressure that would be caused. So I bring that up to recognize this. Dewatering can be a really complicated thing. It's not always a cut and dry, drop this, trash pump into the box and we're good to go. Some job sites and conditions, depending on the rainwater runoff, the types of soils that we have, it may require more of a complex dewatering system that's like a well point outside the system, because only when those conditions are done where it's outside the system do we alleviate removing that additional hydrostatic pressure against that particular shield. And that can make it very difficult when we talk about the removal process and cause damages to certainly the shield and also any ripping that may be going through to try to remove that particular box or even slide rail system from that application. So just know that, those types of solutions can be engineered, and we certainly want to be able to help that if there's ever an opportunity for that. I'd like to kind of pause now, see if we have any questions, Robert, that may have come in. And again, I really appreciate everyone's time today in covering this important topic.
Thank you, Joe, for that absolutely fascinating presentation. I learned a lot. Let's now open the webinar to questions. You can use the chat feature to submit a question, and I'll read the question to the presenter. Or if you prefer, unmute yourself, state your name and company, and ask the question directly. Remember to remute yourself after you finish. There's also the Q&A feature as well, too, in WebEx. But if you stick with the chat, they're probably easier. Joe, I've got one opening question here. Can you use spreader bars to lift vertically or push a trench box while inside the trench?
Great question. So again, this would be something I would encourage you to specifically look at the manufacturer's tabulated data. The response I'll give you is, number one, I know there is one manufacturer that specifically prohibits it, and it's spelled out in their particular tabulated data that cannot be done. Think about it. Obviously, it's the easy thing to consider, but when we do put that type of stress on a spreader bar, we have the great possibility of causing deflection, weakening that particular structural member that's designed to withstand not a vertical load, but to press against the walls of the trench of where that support's needed. So some of them will not necessarily say anything about it, but it's recommended as an industry standard not to. Some boxes will have what they call lifting eyes, and there's different hoisting points of where we can lift them or move them. So it's important to fall back on the manufacturer's tabulated data. But I would just encourage you that, look, if this is something that's being done, it again, follow the guidelines of the manufacturer, but even if they don't state it's not necessarily prohibited, you really need to make sure we're doing proper inspections of spreader pipes. We don't want to be using boxes with pipes that are bent. It can really cause for a false sense of security. It's not proper use. That should be removed from service. And there's guidelines even that certain manufacturers will have about doing, proper inspections of spreaders as it relates to that.
Thank you, Joe. If there are other questions, of course, please use the chat feature. You can unmute yourself. Joe, I have another one. Does tabulated data need to be on the site at all times?
That's a good question. Not necessarily at all times, but when it is needed, specifically OSHA says during the construction process. So the parts of the job where you're using that particular shield or shoring solution that's manufactured, because again, we want to lean on that for proper installation, removal, and limitations of that in the applications and the soil conditions we're in.
Thank you. I've got one more, and then we'll probably end up wrapping it up. Are thin form boards always required when using hydraulic shores?
They are not. However, this requires that the competent person is doing soils analysis to determine, for example, that most manufacturers, if it's a B soil or better and meets that strength, that if it's within a certain depth and we're spacing our cylinders, like we said, it can be done without that backing. Remember, I did mention that that's not a structural member of the protective system. It's how the cylinders are placed and the amount of pressure that's exerted against them by using the bucket pump. So if we are doing the soils analysis, we can fall within the limits and criteria of the manufacturers. We don't necessarily have to have fin form boards. I'll also make this note. Many times you may be getting those from providers, those that provide it as a vendor. Keep in mind that it's always a best practice to send the fin form board out with those shores, always. Why? Well, we can't always assume we're going to be at a B or better soil. We know soil conditions can change. So many times, again, this is perhaps a practice where customers, contractors may own their own equipment. I would just highly encourage you to certainly not just disregard it. You have to make sure that that soil is rated for the strength of a B or better. And it will be also important that a competent person has to monitor for any raveling or sloughing of soil from the face of that trench wall as an added protection, again, to the employees.
Thank you, Joe. And it looks like we have one more. Can the competent person perform other duties, I guess, during the excavation?
Yes, they can. And so, that's often been a question that comes up in our training classes. And, a competent person certainly has to be the one to do the soils analysis. We know, too, that daily inspections, whenever it can be reasonably anticipated that employees could be in harm's way or of a hazard, they have to be done by a competent person. Any dewatering operations and the oversight of that has to be done by a competent person. But as far as always being on the job site, it's, again, the oversight can be delegated, but it has to be something that is monitored, and the competent person has to be, connected to that job, but not necessarily physically there at all times. I hope that kind of helps that. But again, as conditions change, the elevation of that need for a competent person, they can certainly perform other duties as long as things are in check and the requirements are being met, both from the manufacturer, if it's tabulated data, or certainly the overall excavation and the 12 general requirements that are necessary for us to oversee.
Thank you, Joe. And if there are any other questions, and it appears that they're not, and we're at 45 minutes in, let's go and wrap this up. Joe, thank you very much for your time today to present this information to our guests and to myself. I learned a lot. We would also like to thank United Rentals for the continued and very kind support of NUCA and our educational webinar series. Today's webinar will be recorded, and a copy of the recording will be provided to all registrants and attendees. A recording of this webinar will be also made available on the NUCA.com website, along with the PowerPoint and our YouTube channel over the next few days. And thank you for your time today to join us for Webinar Wednesday and supporting NUCA. Our next NUCA Webinar Wednesday will be held on July 7th, sponsored by another NUCA national partner. We couldn't provide our membership services without their kind help. Thank you for your time this afternoon, and please enjoy the rest of your week.